Hello everyone. In this lecture, we will learn about insertion of a given node in the single linked list at the last location. Now let's understand it with the help of the example. So this is a given example in which we have two nodes. This is the first node and this is the next node. And because the second node is also the last node of the linked list, so the address, the next part of this node is containing null. It means that it is not pointing to anywhere. And this start pointer stores the address of the first node. Now what we will do is we will assign a node 1, we will take a pointer node 1 which will contain the address of the first node, and then it will keep on traversing until and unless we find a node whose next part will contain null. Because when it will find a node which will contain its next part as null, it means it is the last node. And when this is the last node, then this will no more be the last node when we will insert one more node after this. So that is the reason why we are taking this pointer node 1, which will contain the address of the first node, and it is going to traverse throughout the linked list until and unless it finds a node in which the next part contains null, and that shows that that is the last node of the linked list. And after that, finding the last node of the linked list, we are going to insert a new node after that node to make it as the last node of the linked list. Now, as we know that in this case, this node 1 is pointing to the first node, which contains the address of the first node, which is also stored in start. So after that, as we know that the next part of this node does not contain null, but it stores the address of the next node. So this node will be shifted to the next node. Now node 1 has been shifted to node 1 next, and this is node 1, and node 1 next is this node. And when you reach to this node, here you find that the next of this node is null. Now we come to know that this is the end of the linked list. So when this is the end of the linked list, we will now introduce a new node which we will take from the away list. So if away list is equal to null, it means the memory is full. But if there is some memory location free, then we will take some free location memory from the linked list, away list. And here I have taken a new node. I have taken a node from the away list and I name that node as new node, right? So it also has two parts. So what we will do is in new node's information, I'm going to store data. So data has been stored, and in new node next is now going to contain null, because now this is the last node that we have inserted. And so we need to change this pointer also, because this is no more the last node of the given linked list. So for that, the node 1, because now still node 1 is storing the address of this node. So in node 1 next, we are going to store the address of new node. So this node 1 next, this is node 1 next part. It is going to store the address of the new node, and in this way we will change the pointer here also. So node 1 next will store the address of the new node, and in this way now we can say that they are connected, and this node has become the last node of the linked list where it contains null. But this node now can no more contain null, but contain the address of the new node that has been inserted. So now you can see here in linked list that whenever we have to insert any node, we have to just change the pointers. But in case of inserting a node at the last, we have to traverse the complete linked list. So it is going to take the time here will be dependent on the number of nodes being traversed, right? So now let's understand the algorithm. So as I have told you earlier also in the previous lecture, that first of all, let's understand it from scratch. So this is the algorithm for insertion at last, and the name of the algorithm is insertion underscore last. And these are the three input parameters: start, avail, and data, where start contains the address of the given linked list, then your avail contains the address of the avail list, and data is the value that we have to insert. So first condition that you need to check is, again, if avail is equal to null. If avail is equal to null, it means that your avail pointer is not pointing to any free location, and it is not pointing anywhere, it is pointing to null. It means that there is no free location in the memory, and if there is no free location in the memory, it is not possible for you to insert anything into the memory. And that is why we will simply say that it will say that this is the condition of overflow, and it will exit. So there is no space present to insert any new node. Now coming to the next step. So in this case, we will understand that if your start is equal to null, and what does it mean? Start is equal to null means start is not pointing to anywhere, right? So it start is not pointing to any address location. It means your linked list is empty. You have not inserted anything into that. As we have discussed in the previous lecture, that when you have to insert the very first node, what are the different ways of inserting it, that we have properly understood it. So first we will create a new node that we will take from avail, and this new node will contain the address of the first node of the avail list, and then your avail will shift to the next of avail. So it will be now pointing to the next node of the avail list, and then new node information will contain data, and new node next will contain null, because this is the first and the only node available in the linked list. And then finally your start will point to the new node that has been created. This has already been I have already created a video for this, and there I have clearly explained you how it is being implemented with the help of the example. Now in the next part, so in this case it was showing that the linked list was empty, but the another case can be in the else part, that there are already available some nodes. So already there are some nodes available in the linked list. So what we will do, as we have understood in the example also, we will create a pointer node one which will store the address of the first node. So it first node addresses of the linked list is being stored in start pointer. So that will be allocated to node 1. Now we will run this while loop, in which we will say that until and unless you don't find a node whose next part contain null, so you will keep on incrementing the pointer and you will keep on traversing the nodes through the addresses given. And if you find a node where the node 1, where the node next part contain null, then you will stop there, which shows that this is the last node of the given linked list, right? So every time your node 1 pointer is changing, because initially it was storing the address of the first node, and when we find that the first node is again containing the address of the next node, so next time your node 1 will contain the address of the second node. Then similarly, if the second node is not the last node, then your second node is also pointing to some other node, third node. So then this node 1 will store the address of the third node, and in this way it is going to traverse till the node which contains null in the next part. Now finally, with the help of this step, we will reach to the node which contains null in its next part. Now let's understand it visually also. So first of all, what we will do is, I have taken an example here where there are two nodes already available. So what we have done is, as I have told you, we have a pointer node 1, and this node 1 pointer will contain the address of the first node, that is 5000, right? And we are going to traverse it. Okay, so we can assume that there is only one node available in the linked list, and then whenever you have to insert a new node, let's take this node from the avail list, and this node is called as the new node. Because of to make you clearly explain this, and because I don't have more space over here, so I have just taken two nodes. So this is the first node, and you can see that in node 1 next part there is null available. So there can be any number of nodes, but here in this example I have taken only one node, and as you can see that node 1 null next part contain null. So it shows that this is the last node in the given linked list. So I have borrowed one node from the avail list. So now your new node, this new node is going to contain the address of avail list. What is that? 1000. So 1000 is being stored in new node, and then now your avail is going to point to the next node, which is 2000. And how it is being done? So your avail is going to store the address of avail next, and because earlier this was avail and avail next is what? 2000. So automatically it will now store the address 2000. It means now it is pointing to 2000, and this is the next free location in the memory. Similarly, all these are the free nodes available, but this is now being used for inserting some data. Now in new node information, we will store some data, and in new node next you will store null, because now this is the last node in the linked list. And then this node 1 next will contain the address 1000. So it is no more going to store null, but it is going to store 1000. So in this way we can say that now these two nodes have been connected. But as I have told you, again if you want to create one more node, So for that, as you have told you, avail is storing what? Then this node address. So now I have taken this node from the linked list, and the address of this node is what? 2000, right? So now it will store the address of now this will be your new node. So this will be your new node, and now new node will contain the address of the address being stored in avail. So avail is storing 2000. So now this node is also storing 2000 address. Now avail will shift to, now it is not, this node is no more there in the memory. So this avail will now point to the next node, avail next, and avail next was storing what? 3000. So this 3000 will be stored in avail pointer. And then here in new node information, we will store some data, and in new node next we will contain null. So it will store null because this is the last node in the linked list. And in node 1, so actually how we will come to know about this node 1? Again, because there are two nodes, so node 1 will store the address of the first node, which is 5000. And then because there is no null available here, because it is pointing to some address, so node 1 will shift to the next node. And here again we see that this node contains null, so this node 1 now will be stored here, and then node 1 next will contain now 2000. So in this way they are now connected, and we can say that these are the different ways of inserting a node at the last location in the given linked list. Now let's understand the time complexity. So as I've discussed with you, that whenever you have to insert a node in the linked list at the last location, so you have to traverse all the nodes from the first location till the last location. So if there are n number of nodes, then the traversal time will be dependent on the number of nodes available in the linked list. So that is why here the time complexity is directly proportional to the number of nodes. And that is why here the time complexity of inserting an element at the last location is bigger often, which depends on the number of nodes available in the linked list. So this was all about insertion of a node at the last location in the single linked list with the help of example, algorithm, and time complexity. In the next video, we are going to study about insertion of a node at a particular value, before the particular value or after the particular value. So till then, stay tuned to my lectures. Thank you so much.